Differentiation is a process of finding the derivative of a function. It is used to measure instantaneous change and to find the slope of a tangent line to a curve at a particular point. Techniques of differentiation. The first one is constant rule. A constant doesn't change, so its rate of change is 0. Second is power rule. Multiply by the exponent, then reduce the exponent by 1. It works for any real number n. And the third is quotient rule, used when one function is divided by another function. The fourth is product rule. Product rule is used when two functions is multiplied together. Take the derivative of the first and multiply by the second. Then switch. Next is chain rule. It used when one function is inside another function. We need to differentiate the outer and then multiply by the derivative of the inner. 6 is sum and difference rule. Take the derivative of each part separately, then add or subtract them. Moreover is implicit differentiation. We differentiate both sides of the equation with respect to x. While we differentiate y, we need to multiply dy over dx. Lastly is trigonometric, logarithm, and exponential rule. The derivative of trigonometric rule are sine, cosine, tangent, cotangent, secant, and cosecant. And the derivative of logarithm function are based on the inverse of the input, while exponential is used to differentiate exponential function. E to the power of x stays the same after differentiation. For other bases A, multiply by ln.
Hi, my name is Afika Edina. Now I will present the step-by-step differentiation for question 2a. The function given is y equals to ln x cubed multiplied by secant 2x. Since this function is a product of two different terms, we must use the product rule. So for u, we got u equals ln x cubed and v equals secant 2x. Next, we need to find the derivative, u prime and v prime. For u, we write the power rule like this, x to the power of 3 minus 1. This gives us u prime equals to 3x squared over x cubed. After cancelling out the x term, we got 3 over x. For v, the formula table states that the derivative of secant theta is secant theta tan theta. Using the chain rule, we differentiate secant 2x to get secant 2x tan 2x times 2. Bringing the 2 to the front, we get v prime equals to secant 2x tan 2x. Now we substitute these components into the product rule formula, which is u v prime plus v u prime. So after we adjust the position of the term, this is our final answer. For dy by dx, which is 2 ln x cubed secant 2x tan 2x plus 3 over x secant 2x. Now let's move on to question 2b. For this question, our function is y equals to 3 minus x squared over e to the power of 10x. Since this function is a fraction, we cannot use the product rule anymore. Instead, we must use the quotient rule. Let's set the top part as a u and the bottom part as a v. So for u equals to 3 minus x squared and v equals 2e to the power of 10x. Step 2, just like before, we need to find our derivative, u prime and v prime. For u, we differentiate 3 minus x squared. The constant 3 becomes 0. For minus 2x, the power rule gives us minus 2x to the power of 2 minus 1. Which simply leaves us with u prime equal 2 minus 2x. For v, we look at our formula table. The derivative of 10x is secant square x. So when we differentiate the exponential function, e to the power of 10x, multiply it by secant square x. So our v prime is e to the power of 10x times secant square x, which we can write simply as e to the power of 10x secant square x. Now we apply the quotient rule formula, which is v u prime minus u v prime over v square. When we substitute our part, we get the answer. Now we can cancel out the e to the power of 10x from the top with 1 from the bottom. And we're done. This is our final answer.
Hi everyone, for my part, I'll be showing you how to solve question 3 step by step. We need to find dy ds using implicit differentiation. Looking at the equation, our first instinct might be to jump straight into differentiation. But if we do that, this fraction inside the natural log is going to give us a really messy quotient rule. So let's make this easier for ourselves and clean up the equation first. Using log rules, we can split the fraction apart. Ln of x over y squared simply becomes ln of x minus 2 ln of y. Now, look at our new equation below. It has no fraction left, which makes it much safer and faster to differentiate. Now, we differentiate everything from left to right because this is implicit differentiation. Every time we differentiate a term with a y in it, we have to attach a dy dx next to it. First, the derivative of 3y squared is 6y, so we write 6y dy dx. Second, the derivative of ln of x is just 1 over x. Third, the derivative of minus 2 ln of y is minus 2 over y, so we write minus 2 over y dy dx. Fourth, for the sine term, we use the chain rule. The outside becomes a cosine, so we say cosine of e to the x minus 2x, and then we multiply it by the derivative of the inside, which is e to the x minus 2. Finally, the derivative of the constant term on the right side is just a 0. Next, we put all the species together into one line. Our goal now is to get dy dx by itself. To do that, we keep the two terms that have dy dx on the left side and move the other terms over to the right side by flipping their signs to negative. Now, we factor out dy dx on the left side. To finish up, we divide both sides to get dy dx completely alone and multiply the top and bottom by xy to clear out the inner fractions. This gives us our final clean answer on the screen. Thank you, and I will now hand it over to my teammates for the next question.
For the question number 4, we have 5 steps. The first step is we have to identify the x1. So our x1 is 7.98. So let's move to the second step. We have to find the x0. So what is x0? X0 is the nearest whole number to x1. So our x0 is 8, which is 8 is the nearest number to 7.98. So number 3 is we have to find x minus x0, which is 7.98 minus 8. So we get negative 0.02. Step number 4 is we have to let fx is equal to x squared minus 1 over cube root of x. So x squared minus 1 over x to the power of 1 over 3 and x squared minus 1 minus x to the power of negative 1 over 3. So next we have to find f prime x. So 2x plus 1 over 3x to the power of negative 4 over 3. So 2x plus 1 over 3x to the power of 4 over 3. So step number 5 is we have to substitute into the formula. So the formula is f prime x approaches to f x naught plus f prime x naught times x minus x naught. So f8 plus f prime 8 times negative 0.02. So here we get. So 8 square plus 1 over cube root of 8 plus 2 times 8 plus 1 over 3 times 8 the power of 4 over 3, and we will multiply it by negative 0.02. So here we get 129 over 2 plus 798 over 48, and we multiply by negative 0.02. So our final answer is 64.18. Thank you.
In conclusion, techniques of differentiation are vital tools in mathematics. We use basic rules like the power, product, and chain rules for standard functions, while applying advanced methods like implicit differentiation and linear approximation for more complex equations. Ultimately, mastering these concepts helps us understand exactly how different quantities change in the real world.